Hi everyone. Okay, so now I'm going to go over the properties of the functions we've talked about before. And so I'm going to write them out. Hope I fit them in the screen. Okay, first one is negative infinity to infinity, the integral of f of t times delta t minus t naught dt equals f of t naught. Given that f of t is continuous at, oh, that was an ugly at. Okay, at t naught. Okay, that's the first one. Second one, the integral from negative infinity to infinity of f of t minus t naught times delta t equals f of minus t naught. Given that f of t is continuous at t naught. Oh, minus t naught. Minus t naught. Okay. Next property is f of t times delta t minus t naught equals f of t naught times delta t minus t naught, given that f of t is continuous. Please fit continuous at t naught. Okay, let me scroll up a little. Hopefully everything fits in one screen. Okay. Delta t minus t naught equals the derivative of u t minus t naught. And u t minus t naught equals the integral from minus infinity to t of delta tau minus t naught d tau equals 1 at t greater than t naught and 0 at t less than t naught. Ooh. Let me see. Okay. Let me scroll up. Okay. Where am I? Okay. The integral from negative infinity to infinity of delta at minus t naught dt equals 1 over the absolute value of a times the integral of minus infinity to infinity of delta t minus t naught all over a dt. Oh, that's an ugly dt. Okay. dt. And lastly, we have delta. Okay. Minus t equals delta t. Okay, so let me zoom out to have them all on one page. Okay, so memorizing these properties would be useful, but there's actually a couple that you can derive on your own. And so I'm going to do the proof of the first one so you can learn how to know how to derive them. And that way you don't have to memorize it. And you could also learn how to manipulate these signals that we've learned to accommodate your needs. So let me write the first one. Minus negative infinity to infinity. What is the first one? Of f of t delta t minus t naught dt. And we're trying to prove it equals to f of t naught. Okay. Okay, so let's break it up. Let's look what's on the inside of the integral, because it's what is in the inside that counts. So then, let me look at this function. This is the impulse function centered around t naught. So let me draw that out. That's the impulse function. That one. at t naught. Okay, and so let me draw a generic. Actually, let me label this delta t minus t naught. And so let me draw a generic, just some random function. Actually, wait, let me make it a different color to keep it consistent. And I'll call this f of t. So on the inside of the integral, f of t is being multiplied by this impulse function centered at t naught. And so if we're looking at the impulse function, it's 0 elsewhere except at t naught where it's 1. So that means outside of this area, it's being multiplied by 0. So 0'd out. And so at this one point, t naught is being multiplied by 1. And so this point here ends up being f of t naught. Because it's basically f of t naught times 1. And so if you take the integral of this dt, you're doing the integral in the variable t. But this is a constant, right? Because it's just a number. And so that ends up just being f of t naught. Yeah. And so you can solve some of the other properties in the same way. And once you do, you'll start learning how useful these functions are. And so I suggest you practice that. But yeah, that's it for this video. Thank you for watching. See y'all next time.